Hi everyone, Junior Liu here. So welcome to another tutorial. On this video I would like to talk about defining constants in C programming and start talking about type qualifiers and and a little bit more on preprocessor directives, right? So let's start by writing our C program, basic standard IO main. So there are two ways basically in C programming language that you can define a constant value, right? So one way is to use a preprocessor directive such as define, and then we assign the name of the constant, for example buffer size, which is very common. You will see plenty of there, and then for example an int number like this, and that's it. Or let's say we want to define a buffer like this, const unsigned int buffer size. Usually you will see that in C programs, for when you define a constant using define, the preprocessor directive, you will see the name of the variable all in caps lock. And that's a good practice, just convention and so forth. So here we will assign, we declare a global variable with 128, right? So let's try to print it, these variables. And so it's unsigned int here, we call it buffer size, and then we refer to it by buffer like this. And the thing with preprocessor directives, you see that here it's actually okay. So let's try to compile. And run. So no by warnings, and it works. So what happens if instead of u here for unsigned, we try to call it like t? Compile normally, nevertheless. So so basically there is no well-defined type here, but I guess when looking at the assembly, when we disassemble, we can try to figure this out. So what will happen if we try to modify, I will leave it just unsigned int, when we try to modify a constant value, right? So let's check it out. It compile, and apparently it's we didn't modify the value here. We just asked printf to print a buffer size +1. So let's create here an unsigned int, call it x, and then we actually don't need, we just say buffer size is equal to buffer size +1, okay, like so. So we're trying to modify a value variable which is supposed to be constant. Okay, so let's see if it compiles. The compiler gives us an error, assignment of read-only variable buffer size. So by assigning const, it interprets as read-only variable, right? So let's try to do that with buffer size. Okay, so assign it to buffer size plus 1. Yeah. Error, L value required as left operand of assignment. So yeah, when you define a variable like this, a constant like this, it really doesn't make sense doing any sort of operations with it. Okay, so yeah, it's supposed to be a constant and must be treated as such. Okay, so yeah, let's try looking how in the assembly, in the binary, these two behave differently, right? So I guess for the sake of simplicity, we can remove these two lines here and then compile it like this, just with these variables. And then we do object dump flag as example 26.0. No, this is not what I'm looking for, I guess, with flag T. Yeah, so it's with flag T. So let's try to find our buffers right here. Okay, so section main, your registers, and then stack. No, I guess that's not really what I am looking for. Let me compile. Oops. Where is our variables? Let me check. Glad, I guess flag T. Data. Let me check. Yeah, let's check the assembly. Yeah, so yeah, that's what I was looking for. So here we got a global variable, buffer size, and then it assigns 4 bytes, and then it assigns 128. Which section is this? RO data. Okay, so our preprocessor directive, I guess it's, where is it? So buffer size, okay, text global main, and here we got a main function. It moves 0 to the EX register, which is the main register for returning function. And I was wondering, where is our 256, which is our buffer or macro. So yeah, move 0 to the EX. Here is the RBP register for the stack, and then return. Okay, LFEO. Main Ubuntu GNU compile, and then we have string u long 0x3. Let's try to see with printf what changes. Oops. Okay, so let's try print buffer size and see if we got, if it becomes easy to identify in the assembly. Okay, so now let's take a look. Okay, so now we got a main function. Alright, so now, so you can see here when calling, where is this buffer size string? So this is a variable that we're gonna print with printf, which is lco. Okay, and then in move to 256 the ESI register. So as you can see, when compiling, these two variables, they behave very differently, and as you can see, it doesn't label or create a variable for our constant sign int, while for macro, like this is preprocessor directive, it substitutes this occurrence here. So the compiler will see, the C compiler, GCC compiler will see this string here, buffer size in your code, and will automatically substitute for the value of 256. So that's the basic. That would be the main difference of it. So you might ask yourself, which ones should you use? It really comes down to a question of a matter of coding style and conventions that you must follow. But we can do a test to see which has a faster access. So we can do like as we have done for other types of tests. We create a loop, and then we try it, we run it for I don't know, it could be 1 million, 10 million times, and we see what we got. So 1 2 3 1 2 3, so that would be a 1 million. Let's try it for 100 million, and I++, and yeah, it will print 100 million times. I was wondering if there is another way we could access this variable here, but yeah, I guess let me think. Yeah, I think we can leave it like this. I believe it won't crash or anything. So let's try with first with the preprocessor directive with the macro, and then we try with the variable constant sign int. So we compile and run, and yeah, it was pretty slow. Let me try something different. Instead of let's try with 1,000 times perhaps. Yeah, it was too fast, so let's increase by power of 10. Yeah, so yeah, I think that's interesting. So let's time that. That will be with the preprocessor macro. So we got almost 3 seconds with the define constant, and then let's try it out with a variable. We have to comment this right here. Okay, and then we time it. So yeah, it was, I guess, let me compile again. Yeah. Yeah, for this case, it was almost the same time, I guess, with minor differences. So yeah, you could say that on this case right here, it really doesn't make too much difference. It really comes down to a matter of coding style. Okay, so as you can see, from the point of view of the compiler, it behaves differently, and I would say its usage is pretty much different when you're writing your own C program. So hope you like this video. Don't forget to like, subscribe, and comment. See you next time. Bye.